Okay, so I don't do very many long form videos, but what we have is a 1.5 horse pump, and sorry, the squirrel in the tree. It's 115 volts, and the issue's been as soon as this pump turns on, the line voltage comes down to a point that this controller will just turn off or black out, and at the same time it will release the contactor and the pump never turns on, comes up to speed. But the pump will work if it can just get up to speed. So it's the inrush current that's drawing and pulling the line voltage down. So what we did was, now this is a smart box, so it has a pressure transducer and a time delay relay, and the main contactor. It's 24 volts for doing everything for the pump, turning on and off. Now, what we used to have this in here, but this is a 24 volt UPS, so uninterruptible power supply. And so the new issue we had this year, because all this went in, a lot of this went in 5 years ago, but starting the last couple of weeks, the issue we had was the combination of the old contactor plus a solenoid on irrigation control valve was drawing too much current, and so it would just not run. As soon as it tried to run, it just stop itself, because hydrolyzed controller, even though this is a PHC 600, only have a 1 amp threshold, so if you move past that, then it will basically stop running. Yeah, I got blood blister on my finger. So what we have is, so we've got our 24 volt UPS. We were using this relay, 24 volt ice cube, to basically switch 24 volts out to that contactor. And originally we were going to do that and just keep the original contactor, but it just chattered still. We could never get these things, it's just not chatter. Now, the one with the green light on is basically, we have a fuse, like a 3 amp fuse, on the primary side of the transformer. So the transformer's here, the power for it comes into here. So we have the line voltage at 120 volts splits off, and there's a fuse in there. It's a glass fast blow fuse. And so we have this on the 24 volts output of that transformer too. The way this goes is 115 volts comes through here, goes through a transformer, and then it's wiring it off, and immediately goes back down into the UPS on the input side. So on that input side is where we have this relay. And now what this relay does is that it keeps the circuit open, and then if it loses power, so if we blow that fuse, it drops power. The controller will still be on because it'll go onto UPS power, but we'll have a sensor on. We have basically a sensor set up that basically tells us fuse blown, and then it tells us this thing stops working entirely. At least we have some idea of what might have happened to it. So basically, like I said, power in, power back, and then output power that actually powers the controller. And we aren't using this relay, so this power is basically getting redirected right to the 24 volt coil of the contactor. We had a little Duracell battery, but we're running just a lantern battery in there, so that comes in 12 volt input into the UPS. And so this has actually worked. I think years ago when I did a line voltage measurement, when this pump was trying to start, we were down to 60 volts. Realistically, the better answer here is to rerun power down here and get off 115 volts and get to 240, and that would, you know, we'd have, well, anyway, we'd if we could get to 240 or just an actual larger wire down here, we'd be better off. But the power was already here, the pump was already here, we just had to make it work. So this is kind of one of those funky things, but it does work, and it works well, and it survived 5 years. So this is version 2 of all this. Like I said, this all stayed, this is new, and that's new. This was an old Pro C cabinet that we gutted out, and so it's got a nice closing door. And then this guy was our actual, this guy was an actual contactor, Hunter contactor box, and so I just throw the keys in the back. But pretty neat stuff. This is what I spent a lot of time working on, is integration stuff like this. So someday we'll cut this post down, put a little cap on it, but so far so good. So if you have any questions, feel free to reach me. I'm going to have leave a comment, but you know, I'll have a couple of short videos too that'll kind of describe some of this in less detail.